Okay, so in the last class, we discussed, we find the solution of second order differential equation with the constant coefficient. Okay, and then we discussed all possible cases. The right hand function is either exponential function or sin x or cos x, all of things, right? Now, maybe I can write the formula for any function. How to find the particular integral of this is second order differential equation, but the right hand side is any function. So if you consider the second order differential equation general form, maybe I can write simply y double dash some constant p times y dash plus some constant q times y equal to some function of x, any function. If this f of x is e power ax, we know what is the particular integral. Okay. Now, so how to find this solution of this one? So first you have to consider the homogeneous equation, and then you have to find the two solution. Okay. So if you consider the corresponding homogeneous equation is y double dash plus p times y dash plus q times y equal to 0. So how to find this complementary function? You got to write the auxiliary equation. You'll get a quadratic equation. You'll get two values, two roots m1, m2. Based on m1, m2, we can write complementary function. Okay. So that is c1 times something plus c2 times something. So therefore, we call this something, this function is y1 and this is y2. Because the second order equation, we can write as two linearly independent solutions. So we call y1, y2. So let y1 of x and y2 of x be two solution, be2 actually a linearly independent solution. So one is not a multiple of other. B2, yeah. Two linearly independent solutions of this homogeneous equation. Two linearly independent solution. I will state the definition how to check two functions are linearly independent. We have to introduce the Wronskian. Okay, so better solution of the homogeneous equation y double dash plus p times y dash plus q times y equal to 0. Maybe so maybe I give something here. We will discuss define what is the Wronskian of two functions. Suppose y1 of x and y2 of x be two solution. Okay, be solutions of the homogeneous equation. So Wronskian defined only for the solution of the homogeneous equation y double dash plus p times y dash plus q times y equal to 0. Okay. Now we define the Wronskian W of y1, y2. That is our Wronskian of y1, y2 is nothing but the determinant of the matrix 2 by 2 matrix y1, y2, and then y1 dash derivative y2 dash, y2 derivative. So what is the determinant? y1, y2 dash minus y2, y1 dash. So this is a Wronskian of two solution y1, y2. If the Wronskian is not equal to 0, then we say y1, y2 are linearly independent. Okay. So we can say if the Wronskian is non-zero. So because you find the determinant, so at a point x, if the W of y1 of x and y2 of x anyway is non-zero, not equal to 0, at least one point x, the Wronskian is non-zero, then y1, y2 are linearly independent. y1 of x and y2 of x, these two solutions are linearly independent. Okay, maybe you can write at x. So Wronskian of x means what? You can y1 of x, y2 of x. So for at least, so this is not 0 for some x. For at least one x, the Wronskian is non-zero, then we can say y1, y2 are linearly independent. Suppose the Wronskian is 0 for all points x. If the Wronskian of y1, y2 at a point x equal to 0 for all point x, then y1 of x and y2 of x are linearly dependent. Linearly dependent. Okay. Maybe we'll discuss some example later. Now, when we say two functions are linearly independent, the Wronskian is non-zero for at least one point. Okay. Now we come back our original case. Suppose y1, y2 be two linearly independent solution of this homogeneous equation. Now, how to find the particular solution of the given equation? We call yp of x. Yp of x means what? The particular integral. P means particular integral. Otherwise, it's what PA. Particular integral of the given equation is nothing but we call v1 into y1 is of the form v2 into y2. Okay. Already we know y1, y2. What is v1? And then what is v2? So maybe we can, it will take some theory, but I am directly write that. So this is nothing but y1 into, sorry, in v1 value is minus thing, therefore minus integral y2 of x into the right hand function f of x whole divided by the Wronskian of y1, y2 into dx plus y2, that is otherwise y2 of x into integral y1 of x into the right hand function f of x by Wronskian of y1, y2 into dx. So this is a formula for finding the particular integral of a second order differential equation with constant coefficient. The right hand side is any function f of x. If f of x sin x or cos x or e power ax or combination of the three functions, we know some formula, we can directly find the particular. Suppose other than this function, we can use this formula to find the particular integral. So we can easily find y1, y2, okay, because it's a very constant coefficient. We can easily write the auxiliary equation. From the auxiliary equation, you can find y1, y2. Okay. So therefore, just to substitute the values here. So far, you got to find the Wronskian of y1, y2, and then substitute everything and then integrate. You will get a particular integral. Okay. Maybe I solve one problem quickly to this exercise. So solve d square minus 6d plus 9 times y equal to 1 by x. So this 1 by x is nothing but x power minus 1. But so far we discussed x power m, but m is positive integer. But here we x power minus 1, that is negative. Therefore, this function f of x is perform any other thing. Okay, now how to find the solution? So first you have to find the auxiliary equation. So auxiliary equation, therefore m square minus 6m plus 9. So this is nothing but actually m minus 3 whole square equal to 0. So therefore the solutions are m equal to 3 comma 3. It's repeated. Therefore, what is the complementary function? c1 plus c2x times e power 3x. Okay. So just to multiply e power 3x inside, therefore we get c1 times e power 3x plus c2 times x into e power 3x. Therefore, our y1 of x is y power 3x. Y1 is e power 3x, and y2 of x is x into e power 3x. So these are two solutions. Now we have to check this is linearly independent or not. Now we have to find the Wronskian. So what is the Wronskian of these two functions? These two solutions. Wronskian of y1 of x comma y2 of x. Anyway, at a point I can write at x here. So y1 y2 dash minus, so I can directly write the formula y1 y2 dash minus y2 y1 dash. Now what is y1? E power 3x. What is y2 dash? You have to differentiate y2 dash. You have to apply UV method. So y2 dash, you have to fix x and then differentiate e power 3x. We get 3 times x e power 3x. Plus, if you fix e power 3x and then differentiate x, we get e power 3x. So this is equal to 3x e power 3x plus e power 3x minus you have to fix y2 and then differentiate y1, you get 3 times e power 3x. Now multiply this, you can cancel this, okay, multiply. So we get 3x e power 6x plus e power 6x minus 3x e power 6x. So we can cancel this, we get e power 6x. So exponential function is always non-zero. Okay, even if you take x equal to 0, e power 0 is 1. Therefore, the Wronskian is non-zero for x equal to 0. Therefore, its Wronskian is non-zero for any other point. Therefore, anyway, y1, y2 are linearly independent. Anyway, the Wronskian of y1, y2 is e power 3x. So e power 6x is the Wronskian. Now, since y1, y2 are linearly independent, it's non-zero. Therefore, what is the particular integral? Yp of x. Particular integral is minus y1 of x into integral y2 into f of x. But f of x is 1 by x. Okay, you can write the formula again. Wronskian of y1, y2 into dx plus y2 times integral y1 of x into f of x by Wronskian of y1, y2 into dx. Now substitute the y1, y2 value, Wronskian value. So what is y1? We are e power 3x, therefore minus e power 3x is the y1 of x integral. What is y2? X into e power 3x is y2. What is f of x? The right hand side function 1 by x. Whole divided by what is the Wronskian? E power 6x into dx. Plus what is y2? Y2 is x into e power 3x integral. What is y1? E power 3x into what is f of x is 1 by x. Whole divided by e power 6x into dx. So you can cancel this x in the first integration and then take this e power 6x to the numerator. We get minus e power 3x integral. E power 3x, e power minus 6x, you get e power minus 3x into dx. You can cancel the x. Plus x into e power 3x. So we can write this as x power minus 1 because 1 by x power minus 1 e power minus 3x into dx. Because if you take the e power 6x to the numerator, we get this one. Now integrate it. So minus e power 3x. If you integrate e power minus 3x, e power minus 3x by minus 3 because the coefficient is minus 3 plus x into e power 3x. So you have to, it's very difficult to integrate this one. So you got to keep it. Okay. So therefore e power minus 3x into 1 by x or x inverse into dx. So therefore the particular integral is minus minus plus. Therefore e power 3 is 1 by 3 because e power 0 plus x into e power 3x integral e power minus 3x into 1 by x or x inverse into dx. So this is a particular rule. So and then finally you can add particular under the complementary function, you will get the solution. Okay. So sometimes you suppose you get here some order step function, you have to keep that one. Okay. So this is a method to find the particular integral or solution of second order differential equation with constant coefficient. The right hand side is any function of x. So we cover all these second order differential equation with the constant coefficient. Now we are going to discuss what about the variable coefficient. Okay, so there are other methods to find the solution of the differential equation with the variable coefficient. The method is called the power method, all the things. But in the syllabus, they are asking only some special type of second order differential equation with the variable coefficient. So we are going to that only. That is called Cauchy homogeneous or Euler-Cauchy homogeneous equation. Okay. Maybe I write the general form of second order differential equation with variable coefficient. Okay. So now we finish that constant coefficient, second order constant coefficient. Now, if you look at the second order variable coefficient, suppose some a naught of x into some nth derivative of yn of x, that is yn nth derivative, plus some a1 of x into yn minus 1 the derivative, any general nth order differential equation with the variable coefficient. So the coefficients are variables, that is the functions of x equal to some r of x something. Okay, so this is general form of nth order differential equation with variable coefficient, where this a naught, a1, etc., an's are functions of x, even is these continuous functions. Okay, a naught of x, etc., an of x are functions of x, are continuous function. Okay, again, this a naught of x should be non-zero, otherwise it is not a nth order differential equation. Now we take the particular case of second order. If we take n equal to, now if we take the n equal to, we get a naught of x into y double dash, some a1 of x into y dash plus a2 of x into y equal to r of x, like this. But in general, we can use the power method. So power method means what? Suppose we have to assume that we have to find a solution for this one. So we have to assume that y of x is a solution, but we have to assume that x y of x equal to a in x power n, right? The power, take the power series. Okay, you have to assume that this is a solution, and then you have to do calculation. But we are not going to this. We are not going to that one. So if we take the special type of equation, but the coefficients are variable, but the special type of function a naught of x is some special type of function, and then a1 of x is something. Okay, we are going to solve that one. So that is given in the syllabus. Okay, but the general method is you have to assume that this is a solution, and then you have to basically find what is this a naught, or what is this ans. Okay, you have to use the reconciliation and all the things you have to do. Okay, but so in this case, we are going to discuss Euler-Cauchy, sometimes called the Euler-Cauchy equation. Euler-Cauchy homogeneous equation. Okay, otherwise Euler's homogeneous equation. Okay, maybe they sometimes called Euler homogeneous or Euler-Cauchy homogeneous equation. Now, what is the general form of nth order Euler-Cauchy homogeneous equation? Is of the form x power n into y nth derivative. Okay, plus some constant, maybe some h1 or some a1. A1 is constant, x power n minus 1, y power y n minus 1 the derivative, plus a2 some constant into x power n minus 2. So you have to reduce the powers, y power y n minus 1 to the derivative, and so on. Finally, we have a constant, some an into y equal to r of x. Okay. So this is a thing. Now we take the special case n equal to 2. If you take n equal to 2, the Euler-Cauchy homogeneous equation is of the form x square y double dash plus ax, not a of x, okay, a into x. A is some constant, x is a variable, ax y dash plus by equal to some function of x. Okay, maybe we call capital X. Now, how to find the solution? So maybe I can directly write, you have to substitute x equal to e power t. Okay, so you have to substitute x equal to e power t. So therefore, what is dx? If you differentiate, okay, anyway, what is t from this? So just you take the log both side, you will get t. Okay, therefore t equal to log x. So you got to take this one. Now, if you find, we got to replace, maybe we can rewrite this, we can call this equation as 1. So if you take this substitution, this equation becomes, so what is this capital D here? D by dx actually. Derivative with respect to x. Now what is dy by dx? You have to differentiate y with respect to x. So this is nothing but you have to differentiate y with respect to t, and then you have to differentiate t with respect to x. Okay, This is actually total derivative. We get same thing. Okay, so this is nothing but dy by dt. What is dt by dx? So this is actually dt. Sorry, this is t. What is dt? If we differentiate this, we get, if we differentiate log x, we get 1 by x. If we differentiate x, we get dx. So therefore, dt by dx is nothing but 1 by x. Therefore, just to cross multiply x, we get x into dy by dt, so dy by dx equal to dy by dt. So otherwise, x into capital D of y is nothing but, maybe you can, okay, don't use this, there are some other notation, okay. So therefore, we can replace, if you take this substitution x equal to e power t, then therefore t equal to log x, we get, we can replace this y dash by, sorry, x into y dash. We can replace this x into y dash by dy by dt. So similarly, again, if you differentiate, we can replace this x square into y double dash by that d square y by dt square. Okay, so I'm directly right. So what is the equation? So if you take this substitution x equal to e power t, this is a method. You directly substitute x equal to e power t, t equal to log x. This equation reduces to in terms of y and t. Okay, so therefore simply I can write d into d minus 1. So therefore, so this actually, if you cancel, so this actually nothing but, if you cancel this thing, we get x into d. So therefore, d into d minus 1 into y plus d into a, already a is there, a into dy plus by equal to r of x. That is, we have to replace this x square dy by dx by d into d minus 1y. Okay, so if suppose you have to replace x into dy by dx, we have to replace d into y. So you can extend this one. Suppose what we about, sorry, d square, x square d square to x square. Suppose x cube d cube y by dx cube. After the substitution, you'll get d into d minus 1 into d minus 2 into y. Okay, that's it. You can extend any power x. Xn into dn y by dx power n is nothing but d into d minus 1 into d minus 2 up to dn minus 1 into y. Okay. So therefore, if we take this y outside, we get, if you multiply d inside, therefore d square minus d plus ad plus b into y equal to r of x. So anyway, we can take d outside, therefore we can write d square plus a minus 1 into d plus 6 into y equal to 0, y equal to r of x. Now this is the equation with the constant coefficient. So therefore, equation with variable coefficient reduces to equation with the constant coefficient. But we know the method to find the solution of equation with the variable, sorry, constant coefficient. Okay, so you have to find the solution of this. You'll get a solution in terms of y and t. So after that, you have to replace y equal to log x, sorry, t equal to log x. You'll get a solution for the original. Okay, so maybe we'll solve. So the only thing is you have to write this, right? You got to form the equation. Okay, maybe I solve one problem. Exercise. Okay, x square solve x square d square or du square by dx square. You can write anything. So better we can write x square into d square y by dx square. That is the second derivative. Minus x into dy by dx equal to log x. Okay, you have to find the solution. So again, the right hand function is not the usual case anyway. So you have to substitute x equal to e power t. Therefore, what is t? Log x. And again, this you'll get not r of x, you'll get r of t. Some function, some s of t or something. You'll get a function of t. Now, this given equation reduces to dx square into d square y by dx square can be written as d into d minus 1 into y minus x into d, you can write just x, y into yd. So equal to log x can be written as t, where what is here d here now? D by dt actually. D by dt, not d by dx. So therefore you can take y outside, we get d square minus t, and then here we give another d, therefore 2d into y equal to t. Now we know how to find the solution. This is a equation with constant coefficient. Now what is the complementary function? So first you have to write the auxiliary equation. So maybe call this equation number 2. The given equation is 1. Okay. Now solve 2. So this is a second order equation with the constant coefficient. We know what is the auxiliary equation is m square minus 2m equal to 0. Therefore, the solutions are 0 and 2. If you take m outside, we get this one. Therefore, 0 and 2 are roots, right? Or I did a mistake. Oh, sorry. In the problem, I missed one fact. That plus y. Sorry. So plus y. So therefore, here we have 1 plus 1. So here plus 1. So therefore here plus 1. So therefore this is nothing but m minus 1 whole square equal to 0. Therefore m equal to 1 comma 1 are the roots. Okay, therefore we know what is the complementary function. So the complementary function is c1 plus c2 times x, because the roots are repeated, times e power. So okay, not x, you have to take t, because everything here the independent variable is t now. Okay, don't use x. c1 plus c2 times t into e power 1 times t. Okay. So after that, finally you have to replace t by log x. Okay. So maybe now itself we can replace for complementary function for the original one is c1 plus c2 times what is t? T is nothing but log x times what is e power t, e power log x. So e power log x is nothing but just x. Okay, so this is a complementary function for the original problem. Now, what is the particular solution for the equation number 2? So the particular integral of the 2 is 1 by f of d into t. But what is f of d? D minus 1 whole square. Okay. So it's nothing but 1 by, if you take a 1 minus d, you can write t minus 1. 1 minus d anyway, we can write 1 minus d square into t. So you can take this 1 minus t to the numerator. You can use the formula. So therefore this is nothing but 1 minus d, because if we take minus outside, square cancel, we get 1 minus d power minus 2 into t. So again we have a formula 1 minus x power minus 2. Okay. So this is nothing but actually 1 plus 2d plus 3d square plus 4d cube and so on. Okay. This is a formula. What is that? 1 minus x power minus 2. So therefore, expand this, we'll get 1 plus 2d plus 3d square and so on into t. Now apply t inside. If you take the first derivative, we will get 1. The second derivative onwards 0. Therefore, we get just t plus 2. Okay, this is a particular integral for equation 2. But what is the particular integral of equation number 1? You have to replace t by log x. Therefore, we get log x plus 2. Okay. Therefore, the solution for the original problem y is complementary function. Just now we proved that c1 plus c2 times log x into x plus the particular integral is log x into 2. Sorry, log x plus 2. So this is a solution of the given equation. So given any equation like this form, here actually what is a? A is minus 1. In this case, a is minus 1, b is 1. Okay. So the general equation, the f of d is nothing but this one, a minus 1 plus b. So any doubt in this? So this is a method to solve this Euler-Cauchy equation. So just you have to substitute x equal to e power t, therefore t equal to log x. The given equation reduces to constant coefficient. Once you have constant coefficient, we have a method. Okay. Now, maybe a general case, I can say that there is sometimes called a Legendre linear equation. But Legendre linear equation not in the syllabus. But Legendre, the Euler-Cauchy equation, but particular case of Legendre linear equation. Maybe I state that. So what is that? So Legendre's linear equation. So the equation is of the form, the general nth order is nothing but ax plus b whole power n, that is a function, into y power n, that is the nth derivative, plus some constant times, some k1 constant times ax plus b power n minus 1, the n minus 1th derivative of the function, so on and so on. Finally, we get some the constant kn times y equal to some r of x. Okay, or functions of x. Anyways, the function of x or r of x. Capital X. Capital X is a function of x. So this equation is called a Legendre equation. If you take a equal to 1, b equal to 0, you get the Euler-Cauchy equation, right? If you take a equal to 1, b equal to 0, this equation reduces to Euler-Cauchy equation. Now, anyway, I can write what is the, or how to find the solution of this Legendre equation. So same thing. Again, you have to take, instead of taking x equal to e power t, you have to take ax plus b, you have to take t, sorry, e power t. So there we take, okay, power, okay, ax plus b equal to take e power t. So therefore, what is t? T equal to log of ax plus b. That's it. So if you take the case n equal to 2, so maybe in the general case, this you have to replace after the substitution. Okay, this equation reduces to actually a power n d into d minus 1. Okay, better we take n equal to 2 so that you can easily understand. So after this substitution, the given equation reduces to equation with the constant coefficient. So therefore, if we take the particular case n equal to, suppose you have equation ax plus b whole square into y double dash plus some constant k1 times ax plus b times y dash plus some other constant k2 into y equal to some function of x. Okay, so you have to substitute ax plus b equal to e power t. Therefore, from this we can say t equal to log of, if you take log both sides, we get t. Okay, so maybe we call this equation number 1. So therefore, after the substitution, this 1 becomes in terms of y and t. So therefore, the first thing, the ax plus b whole square into y double dash simply reduces to a square into d minus 1 into y plus k1 times this ax plus by into y dash, simply you get a into d plus k2 into y equal to some functions of t, because everything becomes in terms of x, y, and t. Okay? So this is the thing. You have to, now this is the equation with the constant coefficient, we can find the solution. Okay? Maybe we can solve one more problem related to this. Suppose solve 1 plus x whole square into d square y by dx square plus 1 plus x into dy by dx plus y equal to 2 times sine of log of 1 plus x. Okay. Now take e power t equal to this 1 plus x. So therefore 1 plus x you have to take e power t. Therefore t equal to log of 1 plus x. So after the substitution, here a equal to 1, right? Therefore simply the reduced equation is d into d minus 1 into y plus here just d into y plus the y term is y equal to 2 times sine of what is log of 1 plus x is just t, therefore sine t. Now this is a, now maybe we can take y outside, we get the equation what is that, d square minus d plus d cancel, we get d square plus 1 times y equal to 2 times sine t. So this is a equation with the constant coefficient, we can easily find the solution. So what is the solution? So simply we can take the auxiliary equation is m square plus 1 equal to 0. Therefore the solution is plus or minus I. It's a complex root. Therefore the complementary function is e power the real part. Here real part is 0. Therefore 0 times t, okay, times c1 cos of beta x. Here beta is 1, beta times t. Therefore just t plus c2 times sin t. So this is the solution. Now e power n, e power 0 is 1, therefore the complementary function is, you have to replace t by log of 1 plus x. Therefore the complementary function for the original problem c1 times cos of log of 1 plus x plus c2 times sine of log of 1 plus x. So this is the complementary function for the original problem. Now what is the particular integral for the second reduced equation? So therefore the particular integral is 1 by f of d sin t, 2 times, okay, 2 times sin t. So we can take 2 outside, is not issue. So what is f of d is d square plus 1 into sin t. So in this case what we have to do, we have to substitute d square equal to minus 1, we will get 0. Then what we have to do, we have to multiply and then differentiate the denominator, okay. So that is 2x, because we get substitute d square equal to minus 1, we get 0. Therefore you have to take 1x and then differentiate this. So we get 2d times sin t. So 2 cancel, x into 1 by d sin t. So 1 by d is nothing but we know that is integration. Integration of sin t with respect to t. So what is the integration of sine is minus cos. So therefore x times, oh, okay, sorry, not x, yeah, t. You have to take everything is t, not x. Because now our independent variable is t, the reduced equation. So t. So t times what is the integration of cos minus integration of sine is minus cos. Now this is a particular integral of the reduced equation. But what is the particular of the original equation? You have to replace everything in terms of x. Therefore particular integral is minus what is t, log of 1 plus x into cos of what is t, log of 1 plus x. So this is a particular. Therefore the solution is solution for the original equation, complementary function plus particular integral. Just to add, you will get. So give any linear function power. So for example, if you take some other example, maybe I state the problem, but similarly you can prove it. Suppose sometimes give 2x minus 1 square into y double dash, okay, plus 2x minus 1 times y dash plus minus 2y equal to 8x square minus 2x plus 3. So again you have to substitute 2x minus 1 equal to e power t. Therefore t equal to, we get log of 2x minus 1. Therefore this equation reduces to, here a is 2. Therefore a square. 2 square, that is 4 times d into d minus 1 for the first factor into y. The second factor, a into d, a is 2, therefore 2 into d into y minus 2 into y equal to, so here you have to replace it. So what is this? In everything you have to write. So from this you got to solve x. So therefore 2x equal to 1 plus e power t. Therefore x equal to 1 plus e power t by 2. So if you take x square, then take so. Therefore 8 times 1 plus e power t by 2 whole square minus 2 times 1 plus e power t by 2 plus 3. So finally, you'll get a equation with the constant coefficient. You can easily solve it. Okay, after find the solution, you have to replace everything in terms of x. So that is, you have to replace t equal to log of 2x minus 1. You'll get a solution. Okay. Any doubt in this?
No, sir.
Now, maybe we can say one more thing, another topic, orthogonal trajectories. So, orthogonal trajectory means what? Suppose we have a family of curve, okay? So, we can state the next topic is orthogonal trajectories. So what it says, suppose sometimes they give some family of function or family of curves. So for example, suppose sometimes give some f functions of two variable, f of x comma y equal to c, where c is constant. Okay. So if you give different values of c, you will get different equation. Okay. First, simply we can take, suppose I am taking y equal to mx, where m is any constant. Okay. So this is a family of curve. If you give m equal to 1, you get y equal to x line. Okay. So for different values of x, different values of m, you get different curve. Okay. So if you take a m equal to 1, you get y equal to x line. This is y equal to x line. If say take m equal to maybe it's like 18, this is y equal to m, y equal to 2x. Okay. Suppose if you take m equal to minus 1, you will get y equal to minus x graph. So all other possible. So these are all, so different values of m, you will get different curve. Therefore, these are all family of curves. This is a given family. Okay. Now we have to find orthogonal trajectories of this given family. Okay. So orthogonal means what? Is it take the it make the angle to this one. Okay. Now how to find a orthogonal trajectories for this family? So actually, we got to find a new function. So maybe we call this C1. Some just we call C1 is the one family of curve. We got to find another family of function, that is g of x comma y equal to C2. Okay, some family of curves C2, such that this product C1 into C2 should be minus 1. Okay. The product of these two should be minus 1. So that is a condition. Orthogonal trajectory means what? The product of these two should be minus 1. Now how to find this g of x comma y from the given equation? Okay. So that is the thing. So there are some steps. So first step is you have to differentiate, because the given function is f of x comma y equal to some c. It's a given family of curves. It does not contain any derivative of y. Okay. So this, you have to differentiate these. So the first step is you have to differentiate. So anyway, from this you got to find a new function, that is x comma y dash equal to c. Okay. You can solve it. Okay. Because if you differentiate, you will get y dash. So for example, If you take, maybe we start with an example so that we can understand this thing. Suppose better take y equal to some k times x or m times x or c times x, anything, you take anything. So this is a given family. Anyway, function of xy equal to constant, or we can write anything. So y equal to this thing. So differentiate both sides with respect to x. Therefore, we get y dash equal to c times 1. That is c. Okay. But what is c from the given equation? C is nothing but y by x. So therefore, we get a equation y dash equal to y by x. So that is g of x comma y dash. Anyway, equal to c, but here c is 0, equal to 0. Okay. So once you find these, you have to replace, because we need the product is -1, right? C1 into C2 should be -1. So if you know C1, if you know C2, then C1 is nothing but 1 by -1 by C2. Okay, this is the idea. So if you know C2, you can easily find C1. So similarly here, so you have to replace y dash by -1 by y dash. Okay? So that is the important thing. You have to replace y by -1 by y dash. Therefore, this equation becomes 1 by -1 by y dash equal to y by x. Therefore, from this, what is y dash? You just cross multiply, you get minus x by y. Okay. Now we have to solve this equation. Just integrate. So otherwise, what is y dash? Y dash nothing but dy by dx equal to minus x by y. So just separation of variable, we get y times dy equal to x times dx minus. So if we integrate, we get y square by 2, and this side is minus x square by 2. We get some constant. You can take c by 2 or c1 by 2, anything. So just we can adjust these two. So just cross multiply or cancel this 2, we get equation x square plus y square equal to some c or some c2. So this is our required function. So in the already we write lines, right? So orthogonal trajectories of this family of lines are family of circles. If you vary the c value, we'll get a different circle. So the circles are orthogonal trajectories for the straight lines. Okay. So got it or not? So first step is you have to find y dash and then replace y dash by -1 by y dash, and then you have to integrate. Finally, we get a orthogonal trajectories. So any doubt in this? Maybe if you have some other problem to this, we can solve. Maybe I don't know. I don't find any problem now. So any doubt in this, you can ask. Okay, maybe I can find some problem. Orthogonal trajectories. Okay. Maybe I found from some net. Okay, please write. Find the orthogonal trajectories of y equal to c by x. And what is the thing? We will discuss about it. That is y equal to c by x. So what is y equal to c by x? What is the curve? So second problem. So find orthogonal trajectories of the family of function. Find orthogonal trajectories, OT, simply and saying OT, of y equal to c by x. So what is that? Just cross multiply x, we get xy equal to c. So what is the graph look like? Assume that c is positive or anything. Okay. If take a c equal to 1, we get xy equal to 1. So actually, this is like take some rectangle hyperbola, right? If you say some other value, you will get some other thing. So similarly, you will get different all possible this rectangle hyperbola, right? Now we got to find the orthogonal trajectories of this family. So what we have to do, we have to differentiate the given curve. So given the curve is maybe I can cross multiply x, and then we can differentiate. So xy equal to c. Differentiate both sides. But here product of two function, you fix x, differentiate y, we get y dash. Plus fix y, differentiate x, we get 1. Therefore equal to derivative of c is 0. Therefore what is y dash? So anyway we get y dash equal to minus y by x. Okay. Now we have to replace y by minus y and then consider the new equation. So therefore the new equation is minus 1 by y dash. Now the right hand side is same thing, minus 1 by x. Minus minus cancel, just cross multiply, we get y dash equal to x by y. Now we need y. So we have to solve the problem. So what is y dash? dy by dx equal to x by y. Okay. So what we'll get? Again, just cross multiply y into dy equal to x into dx. Integrate, we get y square by 2 minus x square by 2 equal to, I can cancel that 2, okay? We get some constant, maybe you can take c2, given, we can take some other constant, some d. Now, for different values of d, so what is the curve actually this? Y square minus x square, or x square minus y square equal to? Huh?
Circles, no?
No, not circle. X square plus y square is a circle. X square minus y square is, what is it? So that should be like this. Different values of this, you get this one. So therefore, the curve makes the angle that perpendicular angle, okay, for each point. So the blue color is the graph of this one, x square, not this one, x square minus y square. Anyway, you can adjust the minus to the constant. So the orthogonal trajectories of this family is x square minus y square is d. This is not a circle. So circle equation is x square plus y square, but here minus y square. Okay. So this is a method to find the orthogonal trajectories of given family of curve. So maybe you can find some other problem. Okay. Now I found that some problem in the jam exam question. So maybe after this we start the class. So what is the given family is y equal to some constant c1 times x cube. Okay. So orthogonal trajectories of the family of curves, this one are, first option, 2x square plus 3y square equal to c2. Second option is 3x square plus y square equal to c2. The third option is 3x square plus 2y square equal to c2. c2 is some constant. Okay. D is x square plus 3y square equal to c2. So which family are orthogonal trajectories to this given family? So what we do, first we have to differentiate the given family with respect to x. Therefore, if we differentiate these, we get y dash. And differentiate these, we get 3 times c1 x square. Okay. Now, what we have to do? We have to cancel this c1. So therefore, what is c1? x1 by x cube. Therefore, 3 times what is c1? Sorry, y by x cube into x square. So we can cancel this x square. We get 3y by x. This is y dash. Okay. Now replace y dash by minus 1 by y dash. Therefore, this thing is this one. So therefore, from this, what is y dash? Equal to minus x by 3y. So that is, what is y dash? dy by dx equal to minus x by 3y. So just cross multiply and then integrate. So 3y dy equal to minus x dx. So therefore, 3y square by 2, you can take this x into dx this side. If we differentiate, we get x square by 2. We can adjust the constant c2 by 2. Now we can adjust multiply by 2 both sides. We get 3y square plus x square equal to c2. So this is the orthogonal trajectories of the given family. So therefore, the correct one is 3y square, the last one. Last option is the correct. So first you have to differentiate the given equation, and the given once you differentiate, again you will get a constant c1. We have to replace that c1 using the given equation. Okay. So the y dash does not contain any constant. If it contains some constant c1, you have to replace it using the given equation. Okay. So this is okay. So anyway, you can solve any problem to this related to this. Just you have to take the. If I found any other problem, maybe I will let me know. Okay, that's it. So now maybe one more thing is there. Maybe I say it and then stop. Okay. Anyway, this thing is enough. Okay. So in the syllabus, sometimes says the method of separation of variables. Okay, this is the method of separation of variables. Okay. If you know why you might. So that's it. So if anything means I will we will discuss in the next class. Okay. Now I stop the class.